Hello everyone, on behalf of Team Current Affairs Review, I Anthony welcome you all to today's discussion. So before moving further with our today's discussion, let me have a small recap on the previous discussion which we had. In the previous discussion, we had put emphasis on climatic significance of atmosphere, where the general circulation of varied factors affect the atmospheric disturbances. Simultaneously, we have understood the phenomena, that is cyclones and anticyclones, and lastly, the naming and nomenclature of the cyclones. So if you have missed the previous discussion, you can get the link in the description box, or you can visit our channel as well. As previously stated, that Earth's atmosphere is a unique and complex system that is constantly interacting with a variety of forces. So now in temperate zones, the region is frequently depicted with highly variable and overcast weather, which is a direct result of traveling cyclones, or we can say extratropical cyclones or temperate cyclones. Here the mid-latitudes represent a point of convergence for contrasting air masses, and it is there that the cyclones and anticyclones traverse with varying regularity with the prevailing westerly winds. As centers for converging and rising air, these moving cyclones produce cloudiness and precipitation, which further causes changes in temperature and air pressure. So in today's discussion, we will discuss on extratropical cyclones and we will have a detailed analysis of it. So let us segregate today's discussion as well. Firstly, we will discuss the development, structure and movement of the extratropical cyclones. In the second part, we will discuss the theories related to it, that is polar front theory and Baroclinic wave theory. And lastly, we will discuss the life cycle of extratropical cyclones. So let us start our discussion with the first part, development, structure and movement of extratropical cyclones. In both hemispheres, extratropical cyclones develop in areas between 30° and 65° north and south latitudes. The polar and tropical air masses collide in these latitudinal zones, forming polar fronts. So fronts are usually the weather system that is the boundary separating the two different types of air. On these fronts, most of these cyclones arise as a result of wave-like twist or disruption. Generally, the isobars, which are connecting lines of atmospheric pressure, becomes almost circular or elliptical, which eventually take the shape of letter V, which is often termed as V-shaped depressions. In general, the V-shaped depressions are oval in shape, with one part being wider than the other. The diameter of temperate cyclones can range from 160 km to 3,200 km. The vertical extent of an average cyclone is estimated to be 10 to 12 km. At its center, a powerful cyclonic circulation can have pressure as low as 940 to 930 milliwatts, while a mild cyclonic storm can have pressures around 1000 milliwatts. Now, if we look onto the general pattern of cyclonic distribution, it shows the movement of temperate cyclone is from west to east, with frequent trends from southeast to northeast. In other words, the mid-latitude cyclones are subjected to general westerly flow of atmosphere in the temperate zone. Even though there is no definite path which most of the cyclones follow, and it is at least true that there are certain tracks which are most commonly followed. Also, with latitudinal shifting of wind and pressure belts, there is a definite seasonal shifting of belts of cyclones as well. Because of this opposing air masses, which have greater contrast during the winter months, the frequency and intensity of winter cyclones forming in the mid-latitude zones increases. This explains why the weather in the temperate zone is more changeable in the winter than the summer, when the entire atmospheric circulation slows down. Now we have come to the second part of our discussion, that is theories related to it. As weather scientists were driven to investigate and research the fickleness and variety of weather characteristics which are created by air disturbances traveling from west to east in the belt of predominant westerlies. Admiral Fitzroy, an British officer and weather scientist in 1863, explained that extratropical cyclones are caused by the collision of air masses with varying physical properties. Another research is carried by Norwegian meteorologist Sir William Bjerknes and his son Jacob L. Bjerknes, where they worked together towards the end of World War I, and they studied the structure of a number of cyclones over Europe by collecting systematic synoptic observations. Their work resulted in significant improvements in our understanding of extratropical cyclones, which led to the development of the polar front theory of cyclones, which is sometimes known as Burgeon theory of cyclone formation or simply the wave theory. Now in polar front theory, V. Baroclinic and other Norwegian meteorologists devised a theory that adequately explains the origin and development of mid-latitude cyclones. The theory recognizes that the polar front, which separates polar and tropical air masses, causes cyclonic disturbances to strengthen and proceed along the front, following fairly predictable life cycle. Cyclones, according to Baroclinic, form along a front where polar and tropical air masses with contrasting physical properties are moving parallel to it in opposite direction. As we know, the mid-latitude constitute a convergence zone, and it is here that opposing air masses such as cold polar air and warm tropical or subtropical air generally collide. It's worth noting that the polar front isn't a permanent boundary. Another characteristic feature of the polar front is that the fact that the changing seasons as well as positioning of the jet streams above bring about a marked north-south shift in the location. Extratropical cyclones, according to wave theory, form a wave-like twist or perturbations on the front. There are two sets of waves that can result from the process, that is stable waves and unstable waves. The weather has no obvious effect on the stable waves as they build and disappear. In case of unstable waves, they increase in amplitude and cycle. As a result, when a frontal surface is warped in a wave-like discontinuity, cyclogenesis happens. Now on an unperturbed or undisturbed front, there are a number of conditions that can cause an unstable wave to form, like mountains, temperature differences from land and sea, ocean current differences or adjacent disturbances can all impact air movement and create a wave. According to this theory, a cyclone forming wave forms along the front when cold polar air is deflected equatorward and warm tropical air is deflected poleward. The resulting wave is split into two sections. The eastern part of the wave, where the warm air advancing towards the east ascends over a wedge of polar air mass, which is called the warm front. The cold front, which is the western part of the discontinuity, where the cold polar air replaces the warm air by underrunning the warm and lighter tropical air masses. Now the frontal wave's amplitude is increased by the curving motion imparted by the Coriolis force when the conditions are favorable. In addition, the cyclone's curvature has been enhanced. The depression has now progressed to a full-fledged state with two separate warm and cold air sectors. Condensation, cold formation and precipitation are result from the ascent of warm air along the warm front as the wave develops. Because the cold front moves quicker than the warm front, the warm air sector shrinks. The process continues and the slow moving warm front is eventually overtaken by the cold front, which creates an occluded front. The center of occlusion becomes filled with cold air from all sides. The vertical motion comes to halt and the surface pressure rises all around. When the occlusion process begins, a storm is on the verge of dying. Thus, continued occlusion hastens the dissipation of the original depression. Now in Baroclinic wave theory, it is based on the notion that the extratropical cyclones can form even there is no pre-existing front between polar and tropical air masses. It also considers cyclones and anticyclones to be an important component of the overall atmospheric circulation. The most notable aspect of this theory is that it was developed using mathematical approaches and numerical weather forecasting analysis. Now, before understanding the theory, we should understand the term what is baroclinicity. Baroclinicity is a state of stratification in atmosphere when surfaces of constant pressure intersect the surfaces of constant density, which usually depends mostly on temperature. According to Baroclinic theory, north-south wind velocity perturbations are accompanied by vertical velocities in ascending warm and moist air currents and descending cold and dense air currents. Rising air currents cause inflowing air currents from adjoining places. Because of the action of Coriolis force, the converging air currents generate a cyclonic spin. The rotational velocity momentum of air it also increases as it approaches the axis of the rotation. There is a counterclockwise circulation around the center of the northern hemisphere. The rise of the air becomes more violent as the cyclone intensifies. As a result, the condensation and the release of latent heat increases. Now, the cyclone's ongoing intensification result in the proportionate drop in pressure in the cyclones. Now we have come to the last part of our discussion, where we will discuss the life cycle of extratropical cyclones. Now, the life cycle of the traveling wave cyclone has 4 stages: the initial stage, the incipient stage, the mature stage, and the occlusion stage. In the initial stage, the polar and tropical air currents on opposite sides of the polar front blow parallel to the isobars. However, there is an abrupt or sudden change in wind directions over the slanting surface of discontinuity, where the opposing air currents meet, which is known as wind-shear. This eventually leads to the second stage or incipient stage, where the wave is formed. The cold air is pushed in the southward, while the warm air is pushed to the northward. Each air mass has begun to encroach the domain of the other. As a result of this, the pressure field is readjusted and isobars take on a nearly circular shape, which give rise to cyclogenesis. Now in the third stage or mature stage, here the cyclone intensity rises. The wave's curvature and amplitude both undergo a marked increase. The air in the warm sector begins to travel from southwest to southeast, where it meets the cold air. The cyclone has now reached its maximum strength, and the warm and the cold zones are clearly delineated. There is ascending air along the entire surface of discontinuity throughout the cyclone. Cloudiness and precipitation will also occur along the warm and cold fronts if the ascending air mass is moist. As the cold front advances quicker than the warm front, the warm sector becomes increasingly small, and this is when the occlusion happens. The advancing cold front now overtakes the warm front in the final stage, resulting in the formation of occluded front. As a result, the warm sector is gradually pinched off, and the 2 cold air masses eventually merge across the front. This removes the occluded front, and now the cyclones die out. So this frontal cyclone life cycle generally occurs for 5 to 7 days. So this is the end of our discussion. Now we will move further in the next video, where we will discuss the tropical cyclones and its origin, development, and also the formation of tornadoes as well. So to have the detailed analysis of our discussion, you can visit our platform currentaffairsreview.com, and you can get the PDF of the discussion. So thank you guys. Have a nice day.